All right, guys, in this video, we're going to talk about the last little thing. I kind of ran out of time for the last video for this section 3.4 with logarithmic functions. So if you missed the first two videos, the first two lessons, whatever, then make sure that you go and view those. But in this one, we're just going to wrap everything up. But you do need to make sure that you understand logarithms a little bit before you get here. So again, if you missed the lessons, if you missed the first two videos, then make sure that you view those before this one. Okay, so here we are talking about a logarithmic scale. And logarithmic scales are going to be used to graph either very large or very small numbers in an easy way. And we're going to get into a little bit more of the logarithmic scale stuff in our next section, well, in a couple sections from now. But just to kind of get an idea, we don't always see with logarithms and exponential functions and things like that. Sometimes the numbers can get really, really big, really, really fast, or vice versa. It could get really, really tiny, really, really fast. And scientific notation is a really easy way to indicate those numbers in a concise way rather than writing them out completely. But what about graphing, right? Because who wants to graph numbers that are out that far? Now, you could make a table that was like scaled, like what you're seeing down here, where I do things like 10 to the 0 power, 10 to the first power, and I could maybe graph that kind of thing on here. But what will happen is even that can sometimes still be a little bit tricky, because if you see something like 9.9 times 10 to the 9th power, this is actually very, very, very close to where 10 to the 10th power would be on the scale. And so you have to be really, really careful about that. And sometimes that kind of graphing and scaling it by 10 to the whatever powers, that sometimes that is a little bit more challenging. So we're going to come up with an easier way, and we're going to do what I said, like I called it, logarithmic scaling. So on this problem, what they're doing is just kind of taking, they're finding the average amount of space that these different things occupy. So the average person, they said, takes up 1 square foot, which I don't know, that might be kind of generous, but we'll see. The average U.S. home, they're saying about 2,200 square feet, average U.S. city, and then that's when it starts getting so large that they don't want to write the whole number out, so they're using scientific notation, average U.S. state, average, and then the country as a whole. And so what we're going to do to be able to graph these values easier is we're going to add on to our table and use a logarithmic scale. So the very first thing we're going to do, you see part A says convert feet squared to a log scale. And what I'm going to have us do is actually just add on to our table. So that's what you're going to see me do. Now, I don't want to draw on this paper because this is the one I'm using in class, but I remade another one for you guys, okay? So what we're going to do here is we're going to add on to our table. And the way, let's see, this is for part A. We're going to convert this to the log scale. So we're going to say, let's say log base 10 scale, just as an extra little add-on here. Okay, so here's what we're going to do, guys. For each one of these values, what I'm going to do is I'm going to find log of this number. Now, based off of what we've learned before, if you do log of 1, you're always, always, always going to end up with the number 0. I'll prove it to you if we type it in here. It says 0. Oh, gosh. Hard to see that screen. I know. I'm sorry. So I can zoom in a little bit, but I don't want to cut everything off. Okay. All right, so then we're going to do log of each of these other numbers here. So we're going to say log of, 2,200. And it's interesting. They do kind of like break these logs out, which is kind of wild. What you want is this number here at the end, the 3.342-ish. Okay. And then let's keep going. Now we actually can type in scientific notation the way that it looks. So we're going to type in log and then 9 times, and then we're going to say 10 to the 9th power. So you can type that in there, 9.9 times 10 to the 9th power, and that gives us 9.996-ish. Okay. If we do log of the next one, 2.1 times 10 to the 12th power, we got about 12.322-ish. And then let's do log 1.1 times 10 to the 14th. And that's 14.041-ish. Okay. So that was us just adding on to our table using a logarithmic scale. So what I just did is I just scaled everything using a logarithm. Okay. All right, I'm going to zoom this back out just a little so you can see my whole little graph line. Now, what we're going to do there is we're going to graph this info from that table. Okay, so I'm going to go onto my little line and we're going to graph these things and kind of label them a little bit. So the average person on my log scale, we have here that value 0, right? So that's your person. Now we have home 3.3-ish, right? Around in there maybe. Okay, then we're looking at 9.996 for our US city. So that is right there, almost at 10. So we're going to say, is that city? Yeah, city. Then state, we're looking at 12.322. State. And then country, we've got 14. USA. Just like that. Okay? So there's our nice little number line. Now, what you had seen on my other thing in notes had talked about the, if you were to compare it with the feet squared, if you had actually graphed that but decided to use a scaled graph where it was like 10 to the 0, 10 to the 1, 10 to the, right? If you did that instead, I want to pull just up what I have on my filled out notes because I just want you to see how similar these things are. So that way you can just realize it is going to be easier to graph the other ones, I think. But so if you do the log scale, that's what this top one was right here. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, up to 15, right? But if you compare this to what it would have been like if I had graphed it with the 10 to the whatever powers, do you notice how these are like basically the same thing? All these values are in the same place, and this is how I would have graphed that scientific notation, kind of. But the logarithmic scale, you get the same outcome. It's just a little easier to do it. So anyways, that's kind of why we do it, is it makes things easier to graph. Add a little extra step to kind of make your table nicer, but it is overall it makes things easier. Okay, so that was that one in its entirety from my notes page where I've already got it worked out. And so you can see I kind of had these backwards, but it's fine. Where we did the logarithmic scale, I put it on this side when I did my notes because I ran out of room. But you can see those are basically the exact same thing. So anyways, that's all I had. That was the last example. And now you can go forth and do your homework. Good luck, and I'll see you on the next one. Bye.